Hey, I'm Abhishek, and in this project, I worked on analyzing the Calgary HTTP web server log dataset, which contains about a year's worth of real world HTTP requests to the University of Calgary. This is a project given by MapUp, and in this video, I'll walk through my approach. I'll walk you through my approach step by step from data loading and parsing to cleaning and answering analytical questions that have been asked. Now, to move on to the part one, which is data loading and cleaning. To begin with, I imported necessary libraries like gzip, datetime, collections, and pprint. Right. In since the log file that was provided to us was in a .gz compressed format, so I used a Python's built-in gzip module to read it line by line. Each line also, since we have imported multiple libraries, here re for regular expressions, re is used for regular expression to pass log entries, and date time to handle timestamps, and pandas, as you know, for strong and a very powerful data analysis is a very powerful and strong data analysis tool. Date time to handle multiple handle timestamps, and counter and default tick for efficient counting operations. Right. Now, here, each line in the log follows a specific log format. So I wrote expression pattern to extract fields like host, timestamp, http request, status code, and bytes transferred. I wrap this in a function called extract log components that takes each line and converts it into a structured dictionary. From each request, I also extracted the file path and its extension and convert the timestamp into date object for further analysis. Right. Now, after that, I built a readzip log function to read the file and return clear data frame of all valid log entries. This way, I can avoid any rows with parsing errors. Once the data is loaded like this here, I print the schema, check for nulls, take a quick look at some rows just to make sure everything is structured correctly. Right. So after that, I get my whole schema overview like this. Now we can move on to the part two, that is the questions based on the analysis of the data. I implemented clean and modular Python functions for this. So let me go through them one by one. Now, for the first one, we are told to find the total number of log records. This is very simple. We just use the length function, and this simply returns the number of valid HTTP requests in the data set, essentially the number of rows in a data frame. Now, moving on to the question number two, this tells us how many clients or IP addresses access the server. I used the nunique function on the host column for this, and the answer for this is 2. Now, to move on to the question number 3. Okay. So, for each day, I calculated how many file paths were requested. This helps understand user behavior across time. Moving on to the question number 4, in which we were told to find total 404 error. Here, I simply count how many times HTTP response code was 404, which means not found basically. It helps identify broken or missing resources. Right. Now, moving on to the question number 5, in which we were told to find top 15 file names with 404 response. In this, I used value count sort function to sort and get the top 15. This shows us files paths triggered 404 errors most frequently. Moving on to the question number 6. Again, top 15 file extension with 404 responses. This is similar to the previous one, but instead of file paths, I grouped by extensions to see if any if say .html or .gif files are causing more 404 errors, right? Now moving on to the question number 7. Here I filter the data for July 1995 and sum the bytes sent per day. This gives insight into data transfer volume, basically, right? And the answer is here. Now moving on to the question number 8. In this, we return a dictionary showing how many requests were made during each hour of the day, helping identify peak hours. For this, I use the function value sort, value count, sort index, and to date. Now, moving on to the question number 9. In this, we were told to find out the topmost 10 requested file names. So, I use the function that returns the top most frequent requested file paths, essentially the most popular resources, using again the function value counts and head, that is the top n, which is where the value was given 10, right? Now moving on to the question number 10. Here we finally count the frequency of HTTP status code to understand the overall success and failure rates of the request. So this was the overall project that was given by the mapper, and I completed it with my whole due diligence. And this project helped me explore real-world web server logs and use Python to derive insights that could help with performance monitoring, user behavior analysis, or server optimization. I thank you, Mapper, for this opportunity. Um, Hope you find my work useful, and thank you.